All right, let's dive into this whole MLOps thing.
Okay.
You've sent over a ton of material, and it seems like you're really digging deep into machine learning.
Yeah.
We've got excerpts from Introducing MLOps by Mark Treveil and the Dataiku team.
Okay.
This deep dive is all about understanding how to take machine learning models from just an idea to a real-world application.
Yeah, it's like taking a blueprint and turning it into a fully functional building.
Wow.
We're going to explore how to streamline that entire machine learning lifecycle,
Right.
making sure your models are not just built, but built to last, adapt, and deliver real business impact.
From what I'm seeing, this book goes way beyond just code.
It does.
It's about creating a robust system where people, processes, and technology all work together seamlessly.
Yeah,
I'm especially intrigued by the idea of responsible AI that keeps popping up.
absolutely. Introducing MLOps emphasizes that it's not enough to just build a model that works.
Right.
It needs to be used ethically, transparently, and in a way that benefits everyone.
Okay.
Think of it like building a bridge.
Okay.
You wouldn't just focus on making it stand up.
Yeah,
You'd also make sure it's safe for people to use.
makes sense.
Yeah.
So first things first, why is MLOps such a hot topic right now?
Well,
What's driving this need for a more structured approach to machine learning?
the book highlights the growing pains many companies are facing as machine learning becomes more integral to their operations. They're realizing that simply building a model isn't enough.
Right.
You need a system to manage it, maintain it, and ensure it continues to deliver value as the world around it changes.
That makes sense.
Yeah.
I can imagine things getting pretty chaotic if you have a bunch of models running wild with no clear plan for managing them.
Exactly. And the book points out three major challenges that MLOps helps us tackle.
Okay.
First, it addresses the ever-changing nature of data and business needs.
Okay.
Imagine training a model to predict customer behavior only to have the market shift dramatically.
Oh, wow.
Without a system like MLOps to adapt and retrain the model, you're left with outdated predictions and potentially bad business decisions.
It's like trying to navigate with an old map.
Yeah.
You might end up completely lost.
Precisely. Second, MLOps helps us manage the complexity of scale.
Right.
As companies adopt more machine learning models, it becomes crucial to have a system to orchestrate them, monitor their performance, and ensure they work together seamlessly.
Right.
It's like having an air traffic control system to prevent collisions in a busy airspace.
Okay. So MLOps is like our air traffic control for the world of machine learning models.
Yes.
What's the third challenge it helps us address?
The book emphasizes the growing importance of responsible use of AI,
Okay.
particularly as we move towards increased automation.
Right.
MLOps provides the framework to build trust and transparency into these automated systems, ensuring they're not just efficient, but also fair, unbiased, and accountable.
It's like installing safety features in a self-driving car.
Yeah.
We want to make sure it's not just getting us from point A to point B,
Right.
but doing it safely and ethically. So it sounds like MLOps is this multifaceted system that brings structure, adaptability, and responsibility to the world of machine learning.
It is.
But who exactly are the players involved in this intricate dance? Is it just a team of data scientists huddled over their algorithms?
Not at all. MLOps is a team sport that requires collaboration from various experts.
Okay.
The book outlines several key roles, starting with subject matter experts.
Okay.
These are the folks who understand the business problems we're trying to solve with machine learning.
Right.
They bring crucial domain knowledge to the table, helping define the problem and ensuring the model's output is actually useful in the real world.
So they're the ones who say, hey, we're losing customers. Can we use machine learning to figure out why and what we can do about it?
Exactly. Then you have the data scientists,
Okay.
who are the masterminds behind building and training the models.
Okay.
They delve into the data, explore patterns, and experiment with different algorithms to create a model that can effectively address the problem.
So they're the architects of the machine learning world,
Yes,
designing these intricate models to solve specific problems.
they are.
And I'm guessing they rely on the expertise of data engineers to get the data ready for their models.
Absolutely. Data engineers are the data wranglers,
Okay.
ensuring it's clean, transformed, and ready for the data scientists to work their magic.
Right.
They build the pipelines that collect, process, and store the data, making sure it's in a format that the models can actually understand.
It's like prepping ingredients for a master chef.
Yeah.
The data engineers make sure the data is ready for the data scientists to cook up some incredible insights.
Exactly.
Now, once a model is built, I'm guessing it needs to be integrated into existing systems.
Right.
Is that where the DevOps team comes in?
Precisely, DevOps teams act as a bridge between development and deployment,
Okay.
ensuring the smooth transition of models into the production environment.
Right.
They handle tasks like setting up infrastructure, automating deployments, and monitoring the system's health.
So they're the ones making sure the model doesn't just live in a vacuum,
Yeah.
but actually gets implemented and used in the real world.
Yes.
And I'm seeing model risk managers and auditors on the list as well.
Yes.
What role do they play in the MLOps world?
These folks are crucial for ensuring responsible AI.
Okay.
Model risk managers assess the potential risks associated with using a model,
Okay.
while auditors make sure everything is compliant with regulations and ethical guidelines. They help us avoid unintended consequences and ensure the model is being used fairly and transparently.
So they're like the guardians of responsible AI,
Yes.
making sure we're not just building powerful models, but
Yeah.
using them in a way that benefits everyone.
Exactly.
Now, I'm also seeing machine learning architects mentioned in the book. What do they do?
Machine learning architects are responsible for designing the overall infrastructure and systems that support the entire MLOps lifecycle.
Right.
They think about things like scalability, security, and maintainability, ensuring the system can handle the demands of real-world deployment.
So they're like the city planners of the machine learning world,
Yes.
designing the infrastructure that allows everything to run smoothly and efficiently.
That's a good way to put it.
It sounds like MLOps involves a diverse team of experts,
It does.
each playing a crucial role in bringing these models to life.
It's a true collaboration. And introducing MLOps emphasizes that clear communication and shared understanding between these teams are crucial for success.
Yeah.
Any breakdowns in communication can lead to delays, errors, and even project failures.
It's like an orchestra. You
Yeah.
need everyone to be in sync and playing their part beautifully to create a harmonious symphony of machine learning.
That's right.
Now, I'm eager to delve into the actual machine learning model lifecycle.
Okay.
The book breaks it down into 4 main stages: model development, preparing for production, deploying to production, and monitoring and feedback. Let's start with the first stage, model development.
Okay.
What exactly happens during this phase?
Model development is where the magic happens.
Right.
It all starts with understanding the data,
Okay.
cleaning it, exploring it, identifying patterns, and basically getting a feel for what we're working with.
Right.
It's like a detective investigating a crime scene.
Okay.
You need to carefully examine the evidence to understand what happened.
So the data scientists are data detectives sifting through the information to uncover the hidden stories within.
Exactly. And once they have a good grasp of the data,
Okay.
they move on to feature engineering,
Okay.
which is all about transforming the raw data into features that the model can actually learn from.
Right.
Think of it like giving the model the right clues to solve the mystery.
So it's not just about feeding the model raw data.
Right.
You need to carefully select and craft the features
Yeah.
that will help it make accurate predictions.
Precisely. And this step requires a deep understanding of the problem domain and the ability to think creatively about how to represent the data in a way that's meaningful for the model.
It sounds like a blend of art and science.
It is.
Using both technical skills and domain expertise to guide the model's learning process.
Yeah.
What happens after we have our features ready?
That's when we get to the exciting part, choosing the right algorithm.
Okay.
It's like picking the right tool from a toolbox.
Right.
You need to consider the complexity of the problem, the data you have, and even ethical implications.
So it's not a one-size-fits-all situation.
It's not.
We need to carefully consider the specific problem and choose the algorithm that's best suited for the job.
Right.
Can you give us a quick rundown of the main types of algorithms and the factors to consider when choosing between them?
Absolutely. We have linear models,
Okay.
which are relatively simple and easy to understand,
Okay.
but might not capture complex relationships in the data.
Mm-hmm.
Then there are tree-based models,
Okay.
which are more flexible and can handle nonlinearity but might be harder to interpret.
Okay.
And then there's deep learning, which
Right.
is incredibly powerful for complex tasks like image recognition, but can be computationally expensive and difficult to explain.
It's like having a range of vehicles at our disposal,
Yeah.
from a nimble bicycle for short trips to a powerful truck for heavy lifting, each with its pros and cons.
Right.
So choosing the right algorithm is crucial for building a model that's both effective and responsible.
Exactly. And once we've chosen our algorithm,
Okay.
we train the model using our prepared data,
Right.
fine-tuning its parameters to achieve the best possible performance.
Mm-hmm.
It's like coaching an athlete.
Oh, yeah.
You need to guide the model's learning process and help it reach its full potential.
So it's not just about picking the right algorithm.
Right.
It's about nurturing its development and ensuring it learns effectively from the data.
Yes.
It sounds like model development is a fascinating blend of data exploration, feature engineering, algorithm selection, and model training.
It is.
What happens once we have a model that's performing well in this development environment?
That's when we move on to the next crucial stage, preparing for production. This is all about ensuring our model can transition smoothly from the controlled world of development to the wild west of the real world.
This sounds like a crucial transition point, taking our carefully crafted model and making sure it can actually survive and thrive in the real world.
It is.
What are some of the key things we need to think about during this preparation phase?
One of the first things to consider is the runtime environment.
Okay.
The model might have been developed using specific libraries and dependencies on a particular operating system,
Right.
but the production environment could be completely different.
Right.
We need to ensure compatibility and make any necessary adjustments to ensure a smooth deployment.
It's like packing for a trip to a different country.
Yeah,
You need to make sure you have the right adapters and clothing to handle the new environment.
exactly.
Yeah.
We also need to think about potential risks.
Okay.
What could go wrong once the model is deployed?
Right.
What happens if the data changes?
Yeah.
What if someone tries to manipulate the model? What security measures do we need to put in place?
So it's like doing a risk assessment before embarking on a dangerous journey.
Precisely. We need to anticipate potential issues and have plans in place to mitigate them.
Okay.
And another crucial aspect is reproducibility.
Right.
Can we reliably recreate the model and its results?
Right.
This is essential for auditing, debugging, and ensuring consistency.
It's like having a detailed recipe for our model.
Yes.
We need to be able to follow the same steps and get the same results every time.
Exactly.
So preparing for production is all about ensuring our model is adaptable, robust, and reproducible, ready to face the challenges of the real world.
It is.
What happens once we've thoroughly prepared our model for this transition?
That's when we move on to the exciting phase of deploying to production, where we actually unleash our model into the wild and let it do its thing.
Okay.
It's like launching a rocket into space, a culmination of all our hard work and preparation.
I can't wait to explore this deployment stage in more detail, but I think we've covered a lot of ground already in this first part of our deep dive.
We have. We've explored the reasons behind the rise of MLOps, the diverse team involved, and the intricacies of the first stage model development.
Right.
Now, in the next part, we'll delve into the critical steps of preparing and deploying our models for real-world impact.
This is already shaping up to be a fascinating journey through the world of MLOs. I'm eager to learn more about how these models are brought to life and the systems that support them.
I'm excited to share more insights with you. Stay tuned for part 2, where we'll unravel the complexities of deploying machine learning models to production and explore the techniques that ensure their success.
Awesome.
Welcome back. I'm eager to continue our exploration of the MLOps landscape. Last time we left off with our model all prepped and ready to face the real world. Now let's dive into the deployment process, the moment of truth, where our model transitions from a promising concept to a live working application.
I'm ready to see how this all comes together. The book talks a lot about CI/CD pipelines, continuous integration, and continuous delivery. It seems like this is the secret sauce for automating deployments and making the whole process smoother. Can you break down what CI/CD means in the world of MLOps?
Absolutely. CI/CD is like having a well-oiled machine for building, testing, and deploying models. It helps us move faster, release more frequently, and catch errors early on, all while maintaining high quality and reliability.
So instead of having a bunch of manual steps and handoffs between teams, we create this automated pipeline that streamlines everything.
Exactly. Think of it like an assembly line for your model. The continuous integration part focuses on automatically integrating any code changes into a shared repository and running tests immediately. This ensures that every change is thoroughly vetted and the code base is always ready for deployment.
So CI is like having a super efficient quality control system built right into the development process. What about continuous delivery?
Continuous delivery takes it a step further by automating the entire release process. This means that once the code passes all the tests, it can be automatically deployed to the production environment, whether that's a server, a cloud platform, or even a mobile device.
Wow, that's impressive. Sounds like CI/CD takes a lot of the manual work and guesswork out of deployment, making the whole process much more reliable and efficient. But what are we actually deploying? Is it just the model itself, or is there more to it?
That's where the concept of machine learning artifacts comes in. An ML artifact is essentially a package that includes everything needed to run the model in production. the trained model itself. Any pre-processing or post-processing steps required libraries and configuration settings.
So it's like putting all the ingredients for your model into a neat little box so you can easily ship it and use it anywhere without worrying about missing pieces.
Precisely. These artifacts are crucial for ensuring that the model can be reliably deployed and run in different environments without compatibility issues. They make the deployment process much smoother and help ensure consistency across different stages of the ML lifecycle.
Makes sense. Now, once these artifacts are built, we need to make sure they're actually working correctly, right? What does testing look like for ML artifacts?
Testing ML artifacts goes beyond just checking if the code runs without errors. We also need to test the model's performance, its robustness to different inputs, and its ability to handle real-world data.
So it's like putting the model through a series of rigorous exams to make sure it's truly ready for prime time. What kinds of tests are involved in this process?
We have a few different layers of testing. Unit tests focus on testing individual components of the pipeline in isolation. Integration tests check how different components work together. And end-to-end tests assess the performance of the entire pipeline from start to finish.
Okay, so we're making sure everything is working correctly on its own, that all the parts fit together seamlessly, and that the entire system is functioning as expected. Now, once we have a well-tested ML artifact, it's time to actually deploy it. The book mentions different deployment strategies like blue-green deployments, canary releases, and A/B testing. Can you explain the differences between these approaches and why we might choose one over the other?
Absolutely. The choice of deployment strategy depends on several factors, including the complexity of the model, the level of risk we're comfortable with, and the need for minimizing downtime during the deployment process.
So it's another one of those, it depends, situations in MLOps. Can you walk me through each of these strategies and their pros and cons?
Let's start with blue-green deployment. Imagine you have two identical environments, blue and green. The current version of the model runs in the blue environment, and the new version is deployed to the green environment. Once the new version is thoroughly tested and verified in green, we simply switch all the traffic from blue to green.
It's like having a backup runway at an airport. You can safely land planes on the new runway while the old one is still in use, and then quickly switch over once everything is confirmed to be working smoothly. So blue-green deployments minimize downtime and make rollbacks easier if something goes wrong.
Exactly. They offer a good balance of speed and safety. Now let's talk about canary releases. Here, we deploy the new version of the model to a small subset of users or servers first. This allows us to monitor its performance in a real-world setting and identify any issues early on before rolling it out to the entire user base.
So it's like dipping your toes in the water before jumping into the pool. Canary releases sound like a great way to minimize risk and gather feedback before making a big change.
Exactly. They're especially useful when you're deploying a model with potentially high impact or when you want to gather real-world data to further optimize the model. Finally, we have A/B testing. This strategy is specifically designed to compare the performance of two different versions of the model.
So instead of just testing a new version against the old one, we're pitting two contenders against each other in a head-to-head competition. How does that work?
We randomly split users into two groups, A and B, and each group interacts with a different version of the model. We then monitor key metrics to see which version performs better, whether that's in terms of accuracy engagement or any other metric that's relevant to our business goals.
So it's like running a controlled experiment to see which model reigns. Supreme A/B testing sounds like a powerful way to optimize model performance and make data-driven decisions about which model to use.
It is. It allows us to gather real-world feedback and make informed decisions based on actual user behavior. Now, aside from choosing a deployment strategy, there's another crucial technique that's often used in MLOps containerization. We've touched on this briefly before, but I think it's worth revisiting in the context of deployment.
I agree. I'm still wrapping my head around what containerization is and why it's so important. Could you give us a quick refresher?
Absolutely. Imagine you're packing for a move. Instead of just throwing everything into a giant box, you carefully organize your belongings into smaller labeled containers. This makes it much easier to transport your things and find what you need later on.
Okay, so containerization is about bringing order and structure to our model's belongings.
Precisely. In the context of MLOps, containerization means packaging our model and all its dependencies, the libraries, frameworks, and other software. It needs to run into a self-contained unit called a container. This container can then be easily moved and deployed to different environments without worrying about compatibility issues.
So it's like creating a portable lab for our model.
Exactly. Tools like Docker are widely used for creating these containers. They provide a consistent and isolated environment for our model, ensuring that it runs the same way, regardless of where it's deployed, whether it's a developer's laptop, a testing server, or a production environment in the cloud.
Containerization sounds incredibly useful for ensuring consistency and portability. But what about when our model needs to handle a massive amount of data or traffic? How do we make sure it can keep up with the demand?
That's where scaling comes in.
Hmm.
As our model becomes more popular or the data volume grows, we need to ensure it can handle the increased load.
It's like building a bridge that can handle not just a few cars, but a constant flow of traffic. How do we approach this challenge of scaling in the MLOps world?
There are two main approaches: vertical scaling and horizontal scaling. Vertical scaling means adding more resources like CPU memory or storage to the existing server where the model is running. It's like upgrading your computer with a faster processor or more RAM.
So vertical scaling is about making our existing house bigger and stronger to accommodate the growing family. But I'm guessing there are limits to how much we can vertically scale.
You're absolutely right. At some point, we hit the ceiling of what a single server can handle no matter how much we upgrade it. That's when we turn to horizontal scaling. This involves distributing the workload across multiple servers, creating a cluster of machines that work together to handle the load.
So instead of just expanding one house, we're building a whole neighborhood of houses to accommodate our growing population.
That's a great analogy. Horizontal scaling is more complex than vertical scaling, but it allows us to handle massive increases in load and traffic.
What are some of the tools and technologies used for horizontal scaling in MLOps?
Tools like Kubernetes are incredibly powerful for managing and orchestrating containerized applications across a cluster of servers. They handle tasks like load balancing, distributing incoming traffic evenly across the servers, as well as resource allocation and even self-healing, automatically restarting failed containers to ensure continuous operation.
Wow, Kubernetes sounds like the ultimate conductor for our MLOps orchestra. It ensures that all the musicians are playing in sync and the music never stops. But isn't managing a complex system like this a huge challenge in itself?
It can be, but that's where the beauty of MLOps comes in. By adopting these practices and utilizing these powerful tools, we can automate many of the complex tasks involved in deploying and scaling machine learning models, freeing up our teams to focus on building better models and solving more interesting problems.
It sounds like MLOps is all about finding the right balance between human expertise and intelligent automation. By carefully orchestrating these different elements, we can create a system that's both powerful and efficient. So we've covered a lot of ground when it comes to deploying machine learning models, from CI/CD pipelines to containerization to scaling strategies. Is there anything else we need to consider before moving on to the final stage of the ML lifecycle?
One final thought I'd like to add is that deployment isn't just about getting the model up and running. It's also about ensuring that the model is integrated seamlessly into the existing systems and workflows within the organization.
That makes sense. A model is only useful if it's actually being used. So we need to make sure it fits nicely into the existing ecosystem and that users can easily access and interact with it.
Exactly. This might involve building APIs, integrating with existing databases, or developing user interfaces that allow people to leverage the model's predictions. The key is to think about the end user experience and ensure the model is seamlessly woven into the fabric of the organization.
This has been an incredibly insightful exploration of the deployment phase. I feel like I'm starting to see how all the pieces of the MLOps puzzle fit together.
Me too. We've covered a lot of ground, but there's one crucial stage remaining: monitoring and feedback. It's not enough to just deploy a model. We need to make sure it's performing well in the real world, catch any issues early on, and continuously learn and improve.
I'm eager to delve into that final stage. I can't wait to see how we close the loop and ensure our models continue to deliver value over time.
I'm excited to explore that with you. Stay tuned for part 3, where we'll unravel the world of monitoring, feedback, and continuous improvement in the MLOps lifecycle.
All right, we've built our model, prepped it for the real world, and successfully deployed it into production. But the journey doesn't end there, does it?
Not at all. Deploying a model is just the beginning. Now comes the crucial phase of monitoring and feedback, ensuring that our model continues to perform well, adapt to changes, and ultimately deliver lasting value.
It's like launching a satellite into orbit.
Yeah.
You don't just fire it off and forget about it. You need to constantly monitor its trajectory, make course corrections, and ensure it stays on track.
That's a great analogy. In the MLOps world, monitoring and feedback are all about creating this closed loop where we gather insights from the real world, use those insights to identify areas for improvement, and then make adjustments to the model or the pipeline to enhance its performance.
So it's a continuous process of learning and adaptation, ensuring our model isn't just a static entity, but a dynamic, evolving system that stays relevant and effective over time. What are some of the key things we need to monitor once our model is out there in the wild?
One of the most important things to keep an eye on is model performance. We need to make sure the model is still making accurate predictions and that its performance hasn't degraded over time.
That makes sense. We've invested so much time and effort in building and deploying this model. We want to make sure it's actually delivering on its promises. How do we go about measuring model performance in the real world?
There are a bunch of different metrics we can use, and the choice depends on the specific problem we're trying to solve. But the basic idea is to compare the model's predictions to the actual outcomes and see how well they align. Are we correctly classifying images, accurately predicting customer churn, or effectively forecasting energy demand?
So it's like checking the model's report card. Is it still getting good grades? Are we seeing the results we expected when we built and trained the model?
Exactly. And this report card might include metrics like accuracy, precision, recall, F1 score, or even more business-specific metrics like customer satisfaction scores or conversion rates. The key is to choose metrics that are meaningful for our specific application and track them over time.
Okay, so we're monitoring the model's performance to make sure it's still doing its job effectively. What else do we need to watch out for in this post-deployment phase?
Another crucial aspect is data drift. This is when the data the model was trained on no longer reflects the real-world data the model is seeing in production. This can happen due to various factors, changes in consumer behavior, new trends in the market, or even the emergence of new technologies.
We talked about data drift earlier, but it's worth emphasizing again because it can really sneak up on you. Can you give us an example of what data drift might look like in practice?
Absolutely. Imagine we've built a model to recommend products to customers based on their past purchases. We train the model on historical data, but maybe there's a sudden shift in fashion trends or a new competitor enters the market with a disruptive product. Suddenly, the model is seeing purchasing patterns that are different from what it was trained on, and its recommendations might become less relevant or accurate.
So the model is like a fish out of water. It's trying to swim in a new environment that it's not adapted to. And this can lead to a decline in its performance and effectiveness.
Exactly. Data drift is a common challenge in machine learning, and it's why monitoring is so crucial. We need to detect these shifts in the data as early as possible and retrain the model on fresh data that reflects the current reality.
Okay, so we're monitoring for data drift to make sure our model stays relevant and adaptable. What else is involved in this comprehensive monitoring process?
Another important aspect is system health. We want to make sure the entire ML pipeline, from data ingestion to model prediction to output delivery, is running smoothly and efficiently. Are there any infrastructure issues? Is the model responding quickly to requests? Are there any errors or exceptions being thrown?
So it's like checking the vital signs of our ML system, making sure everything is functioning properly and there are no warning signs of trouble. How do we keep track of all these different aspects of system health?
MLOps provides a variety of tools and dashboards to help us visualize and monitor these vital signs. We can set up alerts to notify us if certain thresholds are crossed, like a spike in error rates or a sudden drop in model response time. And we can use dashboards to track trends over time and get a holistic view of the system's performance.
It sounds like we have a whole arsenal of monitoring tools at our disposal to ensure our ML system is healthy and running at peak performance. Now we've gathered all this monitoring data, performance metrics, data drift indicators, system health checks. What do we actually do with it? This is where the feedback part comes in, right?
Exactly. The feedback loop is all about using the insights we've gained from monitoring to improve the model, the pipeline, or even the entire system. This might involve retraining the model on fresh data, adjusting its parameters, tweaking the pre-processing steps, or even developing a whole new model if necessary.
So it's a continuous cycle of learning and improvement, using real-world feedback to refine and optimize our ML system. How do we make sure this feedback loop is actually effective and drives meaningful changes?
That's where the principles of MLOps really shine. By automating as much of this process as possible, we can quickly respond to changes, address issues, and keep our models performing at their best. Imagine a system that automatically detects data drift, triggers a retraining process on new data, and then seamlessly deploys the updated model without any manual intervention.
That's incredible. It sounds like MLOps is all about creating this self-learning system that continuously adapts and improves based on real-world feedback.
Exactly. And by closing this feedback loop effectively, we can ensure that our machine learning models aren't just one-time projects, but rather valuable assets that deliver lasting impact and continue to grow more intelligent and effective over time.
This has been an incredible deep dive into the world of MLOps. We've explored every stage of the machine learning lifecycle, from building and training models to deploying them into production and continuously monitoring and improving their performance. I feel like I have a much deeper appreciation for the complexities and the possibilities of this field.
Me too. It's been a pleasure exploring it with you. And as we wrap up this deep dive, I want to emphasize one key takeaway. MLOps is not just about tools and technologies. It's about fostering a culture of collaboration, communication, and continuous learning within our organizations.
That's a crucial point. It's about people working together effectively, using these powerful tools to build and deploy